page 335, number 9, in section 7.5, says that the number, N, of bacteria per meter squared found in unchlorinated water depends on the temperature, T, in degrees Celsius. If the number of bacteria is given by N equals 60T minus T squared, at what temperature will the number of bacteria exceed, there's the key word, exceed 500 units per meter squared. So just forget about all this meter squared business and this degrees Celsius. We don't care about that. And it says exceeds 500 units, so therefore is greater than 500 units. So we know that the function that we're going to be creating has this in it. Greater than 500. Question is, what is greater than 500? That stuff. N is greater than 500. This is the definition of N. So let's just write this down here. And I'm not going to write it down like this, by the way. 60T minus T squared is not the format I like. I'm going to go minus T squared plus 60T. So minus T squared plus 60T. And I'm using a lowercase t because that's what I like. So there's the formula. This stuff is going to be greater than 500. That's what we're asking. Let's just do a little thought experiment here. Let's graph this thing. We're talking about bacteria growing as a result of temperature. So intuitively we know that if it's really cold they'll all die, and if it's really hot they'll all die. And we can see here that this is going to be a parabola, and because it has a negative number it's going to be one of these upward facing ones. So what we're faced with is something like this. A graph like this where if it's really cold they all start dying off, and it's really hot they all start dying off, and at some perfect temperature the maximum amount of bacteria will be found. And we don't know what that is exactly, but the question is the above 500. So let's just assume that that's 500 on the y-axis. And if that's 500 on the y-axis, we're looking for this interval here, this kind of interval on the x-axis that tells us that between here and here in temperature, this is the number of bacteria, in this range the number of bacteria will be greater than 500. That's kind of what we're looking for. If we looked at it on a number line, and I'm just placing 0 here, I don't know if 0 is actually going to be here or not. There is a point here and a point here that corresponds. And the question will be, well, obviously it's greater here. We can see it on the parabola. So if this is actually the t-axis or the x-axis of this graph, this is the range that we're looking for. The question is, what number is that? And what number is that? And if we can figure that out, we know that in between that range it'll be greater than 500. So all the diagramming aside, let's look at this again. Let's change that into a quadratic. Let's go put it over here where I have some space, and we have negative t squared. I'm using the lowercase t, and they use uppercase t in the book, but that doesn't matter. Plus 60t. And I'm going to subtract 500 from both sides, greater than 0. And because it's a greater than, if I was going to graph it, I'd have to use a dashed line. That doesn't matter right now. Okay, so this I can see is factorable. Whoops, that's a 60. Now it's factorable because 500 is 10 times 50, and 10 and 50 is 60. So what we've got here, that's plus, that's negative, that's negative. If we move everything over to the other side, I would get this. So what I did was I added 500 to both sides, I subtracted 60t from both sides, and I added t squared to both sides. Now you'll notice here that the 0 is greater than that stuff. And here 0 is less than this negative version of that stuff. And the reason I did that is I like to deal with positive numbers. I don't like to have a negative number for the t squared because it's easier for me to factor that way. I know that because this one is negative and that one's positive, I've got two minus signs. So it's t minus and t minus 10 and t minus 50. And that means that the two amounts I have here are 10 and 50. These are the values that make this expression true. And on a number line then, there's 0 over here, there's 10, and there's 50. I know that I represent it with the hollow circle and the line between it, showing the space in between. Now I can test it. I should test these regions here. I'll call this region A, region B, and region C. And region A are these numbers that are lower, B are between 10 and 50, and C is greater than 50. Well, if I test it in the original equation up here, and let's say I test 0, well, negative 0 squared is 0 plus 0 greater than 500. No, it's not. So region A, definitely not. Region B, let's try a number like, let's try 20, because that's right in the middle here. So negative 20 squared is 400, plus 60 times 20, and 60 times 20 is 1200, so that's 400 plus 1200 is 1600. Yes, that's greater than 500. Let's go over here. Let's try 100. Negative 100 squared negative 100 squared is negative 1 times 100 squared is negative 10,000 plus 6,000 is negative 4,000 is not greater than 500. Let's try it out again with 20. 20 times t is 400. Negative 400 plus 1,200 still greater than 500. Yeah, that's 800. That's correct. So B works and C does not. So we know that t has to be greater than 10 and less than 50. That's our answer.